Currently, in the world of military aviation, there is an ultimate fighter aircraft on every country's wish list. This advanced fighter jet is known for its unmatched speed, agility, and power, making it a true force to be reckoned with in the sky. The F-15EX, undefeated in aerial combat, the F-15 Eagle epitomizes air superiority in the minds of enemies, allies, and the American people for over 45 years. Although it was not meant to fly forever, the U.S. has responded boldly and decisively with its proven modernized platform to maintain air superiority now and into the future. However, it is believable that an F-15EX will likely approach the Mach 3.2 top speed of the retired Lockheed SR-71 during combat. Is this claim exaggerated? Join us as we unveil the F-15EX, the jet that could be America's ultimate fighter jet. The F-15 Eagle is a dedicated American air superiority fighter developed in the aftermath of the Vietnam War. This jet is based on the experiences gained from the war. It has been the U.S. Air Force's primary fighter jet and intercept platform for decades. According to the U.S. Air Force, it has a perfect combat record, with over 100 victories and 0 defeats. The United States Air Force commissioned the F-15 after they saw the MiG-25, a powerful fighter jet the Soviet Union unveiled in 1967. The MiG-25, commonly known as the Foxbat, was far superior to the primary U.S. fighter jet at the time, the F-4 Phantom. In the heart of the Cold War, the Air Force needed a comparable aircraft, and they needed it as soon as possible. McDonnell Douglas, now merged with Boeing, won the contract for the new project and delivered the finished F-15 a few years later, in 1975. Since then, the company has introduced several variations on this plane as technology and needs have evolved. The current combat F-15 Eagle is the F-15C. The original F-15 Eagle was designed to only handle air-to-air targets. It wasn't built equipped to bomb land targets due to knowing the extra equipment would compromise the plane's aerial combat abilities. However, when the Air Force needed a fighter bomber to replace the aging F-111, until the new stealth F-117 was ready, they modified the F-15 for air-to-ground missions. The result was the F-15 Strike Eagle, designated F-15E. The Strike Eagle is not a replacement for the original F-15, but a supplementary bomber plane. Surprisingly, this temporary solution turned out to be the pride of the Air Force's inventory and one of the best fighter bombers ever made. In Operation Desert Storm, the Strike Eagle proved it could successfully pass enemy planes, hit several ground targets, and then fight out of enemy territory. Let's take a closer look at this air beast by going into its features. The Eagle's air superiority is achieved through unprecedented maneuverability, acceleration, range, weapons, and avionics. It can penetrate enemy defenses, outperform and outfight any current or projected enemy aircraft. The F-15 has electronic systems and weaponry to detect, acquire, track, and attack enemy aircraft while operating in friendly or enemy-controlled airspace. Its weapons and flight control systems are designed so one person can safely and effectively perform air-to-air combat. In addition, the F-15's superior maneuverability and acceleration are achieved through a high engine thrust-to-weight ratio and low wing loading. Low wing loading, the ratio of aircraft weight to its wing area, is a vital factor in maneuverability and, combined with the high thrust-to-weight ratio, enables the aircraft to turn tightly without losing airspeed. The stalling speed, takeoff speed, and landing speed of an aircraft are partly determined by its wing loading. However, the F-15's multi-mission avionics system sets it apart from other fighter aircraft. It includes a heads-up display, advanced radar, inertial navigation system, flight instruments, UHF communications, tactical navigation system, and instrument landing system. It also has an internally mounted tactical electronic warfare system, identification system that detects friend or foe, electronic countermeasures set, and a central digital computer. Through an ongoing multi-stage improvement program, the F-15 receives extensive upgrades involving installing or modifying new and existing avionics equipment to enhance its tactical capabilities. The heads-up display projects all essential flight information gathered by the integrated avionics system on the windscreen. This display, visible in any light condition, gives the pilot the information to track and destroy an enemy aircraft without looking down at cockpit instruments. The F-15's versatile pulse Doppler radar system can look up at high-flying targets and down at low-flying targets without being confused by ground clutter. It can detect and track aircraft and small high-speed targets at distances beyond visual range to close range and at altitudes down to treetop level. The radar feeds target information into the central computer for effective weapons delivery. The radar automatically acquires enemy aircraft for close-in dogfights, and this information is projected on the heads-up display. Also, an inertial navigation system enables the Eagle to navigate anywhere in the world. It gives aircraft position at all times and information on pitch, roll, heading, acceleration, and speed. The F-15's electronic warfare system provides threat warning and automatic countermeasures against selected threats. The identification friend or foe system informs the pilot if an aircraft seen visually or on radar is friendly. It also informs U.S. or Allied ground stations and other suitably equipped aircraft that the F-15 is friendly. The F-15 can carry a variety of air-to-air weaponry. An automated weapon system enables the pilot to perform aerial combat safely and effectively using the heads-up display, avionics, and weapons controls on the engine throttles or control stick. When the pilot changes from one weapon system to another, visual guidance for the required weapon automatically appears on the heads-up display. The Eagle can be armed with combinations of 4 different air-to-air weapons: AIM-7 F/M Sparrow missiles or AIM-120 Advanced Medium-Range Air-to-Air missiles on its lower fuselage corners, AIM-9 L&M Sidewinder or AIM-120 missiles on 2 pylons under the wings, and an internal 20mm Gatling gun with 940 rounds of ammunition in the right wing root. Similarly, the low-drag conformal fuel tanks were specially developed for the F-15C and D models. Conformal fuel tanks can be attached to the sides of the engine air intake trunks under each wing and are designed to the same load factors and airspeed limits as the basic aircraft. Each conformal tank contains about 114 cubic feet of usable space. These tanks reduce the need for in-flight refueling on global missions and increase time in the combat area. All external stations for munitions remain available with the tanks in use. AIM-1 F/M Sparrow and AIM-120 missiles can be attached to the corners of the conformal fuel tanks. How did the F-15 Eagle come to be? We're going to dive into its background. The F-15 is a twin-engine jet fighter produced by the McDonnell Douglas Corporation of the United States, based on a design proposed in 1969 for an air superiority fighter. It has also been built in fighter-bomber versions. F-15s were delivered to the U.S. Air Force between 1974 and 1994. They were also sold to American allies in the Middle East and assembled under contract in Japan. The first F-15A flight was made in July 1972, and the first flight of the 2-seat F-15B, formerly TF-15A, trainer, was made in July 1973. The first Eagle, F-15B, was delivered in November 1974 to the 58th Tactical Training Wing, Luke Air Force Base in Arizona. Pilot training was accomplished in both the F-15A and B aircraft. In January 1976, the first Eagle destined for a combat squadron was delivered to the 1st Tactical Fighter Wing at Langley Air Force Base, Virginia. The single-seat F-15C and 2-seat F-15D models entered into the Air Force inventory in 1979. These new models have Production Eagle Package, PEP 2000, improvements, including 2,000 pounds of additional internal fuel, provision for carrying exterior conformal fuel tanks, and an increased maximum takeoff weight of up to 68,000 pounds. However, the F-15 Multi-Stage Improvement Program was initiated in February 1983, with the first production of MSIP F-15C in 1985. Improvements included an upgraded central computer, a programmable armament control set allowing for advanced versions of the AIM-7, AIM-9, and AIM-120A missiles, and an expanded tactical electronic warfare system that provides improvements to the ALR-56C radar warning receiver and ALQ-135 countermeasure set. The final 43 included a Hughes APG-70 radar. The F-15C, D, and E models were deployed to the Persian Gulf in 1991 to support Operation Desert Storm, where they proved their superior combat capability. F-15C fighters accounted for 34 of the 37 Air Force air-to-air victories. F-15Es were operated mainly at night, hunting Scud missile launchers and artillery sites using the Lantern system. They have since been deployed for Air Expeditionary Force deployments and operations including Southern Watch, a no-fly zone in southern Iraq, Provide Comfort in Turkey, Allied Force in Bosnia, Enduring Freedom in Afghanistan, and Iraqi Freedom in Iraq. The Boeing F-15EX Eagle II is an American all-weather multi-role strike fighter derived from the McDonnell Douglas F-15E Strike Eagle. The aircraft resulted from the U.S. Department of Defense's Cost Assessment and Program Evaluation, OSD CAPE, a study in 2018 to recapitalize the aging F-15C and D fleet due to inadequate numbers of F-22s, delays in the F-35 program, and maintaining diversity in the U.S. fighter industrial base. The F-15EX is expected to replace the F-15C and D in performing homeland and air defense missions and also serve as an affordable platform for employing large standoff weapons to augment the frontline F-22 and F-35. The first aircraft was delivered in 2021, and operational service is expected in July 2024. In the early 1970s, the U.S. Air Force began testing the F-100 series afterburning turbofan engine in the F-15 airplane. The F-100 represented the first of a new class of high thrust-to-weight engines. Extensive ground tests had been conducted, but initial flight tests on the F-100 engines revealed the unusual problems with the new engines. In July 2020, DoD ordered 8 F-15EXs over 3 years for $1.2 billion. Although it is not expected to survive against modern air defenses by 2028 compared to the 5th generation F-22 and F-35, the F-15EX can perform homeland and air-based defense, enforce no-fly zones against limited air defenses, and deploy outsized standoff weapons in the support of stealth fighters at the front line. While not as survivable as the stealthy F-22 or F-35, the F-15EX nevertheless incorporates advanced integrated avionics and protective countermeasure systems to improve the pilot's situational awareness and increase survivability. The Air Force's proposed budget for the fiscal year of 2024 includes funds to buy 24 more F-15EXs, which would bring the proposed fleet up to 104 aircraft. Now let's discuss this mighty jet's power plant, shall we? The F-15EX are outfitted with 2 General Electric F-110 GE 129 afterburning turbofan engines, an improved F-100 engine model. The F-100 PW100 was produced with serial numbers P680050 and P680084. One of these was the F-100 engine with serial number P680063. This engine has since had a long and perhaps unique history. Engine P680063 has flown in 4 major configurations and has been used for several flight research programs for NASA, USAF, and commercial industry programs. Major engine technology improvements have been deployed or demonstrated during these tests. These improvements included the detailed comparison of flight-to-ground facility tests, the first production digital electronic engine control, the first active stall margin control system, the first performance-seeking control, and the first use of computer-controlled thrust for emergency flight control. Ground and altitude facility tests were integrated with the flight tests, providing a good balance between the capabilities of ground and flight tests. The F-100 engine is a two-spool, low-bypass ratio augmented turbofan engine built by Pratt & Whitney in West Palm Beach, Florida. It consists of a 3-stage fan, 10-stage compressor, annular combustor, 2-stage high-pressure turbine, and 2-stage low-pressure turbine. A mixed-flow augmenter exhausts through a variable area balance beam nozzle. The F-15EX remains the longest continually serving fighter of all time. Although the Air Force hasn't received a new F-15 in 17 years, orders from America's allies, including Israel, South Korea, Saudi Arabia, and Singapore, have kept the assembly line in full production. A steady stream of new customers has also kept the F-35 current with the latest technology. When the Pentagon finally decided to buy a new F-15, much of the work of integrating new sensors, weapons, and other capabilities was already complete, thanks to recent overseas purchases. Although the EX model process began several years ago as a combined Air Force effort to bring the best in response capability, Team Eglin and the 96th Test Wing are proud to be a part of the rich history of this legendary aircraft. This new batch of F-15 fighters could easily serve for an additional 35 years, which means the Eagle may become the longest continually serving fighter of all time with a lifespan of an astonishing 82 years. The EX provides a unique opportunity for the test enterprise, as it is the first Air Force aircraft to be completely tested and fielded through combined developmental and operational test efforts. The EX's official role is to meet capacity requirements while bringing diverse technology, ensuring the platform's relevance for decades to come. The 96th Test Wing and the 53rd Wing are set to begin test and evaluation efforts. The 85th Test and Evaluation Squadron will work closely with the 4th Flight Test Squadron to integrate testing from start to finish. The Air Force will procure up to 144 F-15EXs from Boeing to replace F-15C and D models. The goal is to increase the F-15 fleet's readiness. The 173rd Fighter Wing at Kingsley Field Air National Guard Base in Oregon will become the first F-15EX formal training unit in 2024. The first operational F-15EX squadron will function in the Oregon ANG for critical homeland defense alert missions. Since 1985, the F-15 has had a home in the National Guard. Guard airmen have flown these amazing aircraft in the homeland's defense and in every major international conflict since the first Gulf War in 1991. Now that is the battle-tested legacy of the Guard F-15s. First to the fight, always ready, and always there. In conclusion, the F-15EX can integrate with other aircraft and ground forces with upgraded software and communication systems, enhancing overall mission success. Hence, the F-15EX Jet remains a true force to be reckoned with. However, does it set a new standard for upcoming fighter aircraft performance and capabilities? Let us know your thoughts by dropping a comment below. Don't forget to subscribe to our channel for more aviation updates and military technology news. Thanks for watching the video.